So I've rubbed period 4 off, so I've got more space to do something on this part of the board. So let's have a look at what might happen if elements become more stable by losing electrons or gaining electrons. And in this video, I'm going to look at the idea of actually losing electrons and passing them off to another element. And that's called ionization. So let's have a look at how ionization happens in the making of a very, very common substance, sodium chloride. So we have a look at here. Here we've got sodium, and sodium is here in period 3, group 1. If it's period 3, it has its 3 energy levels, and if it's group 1, it has 1 electron in that outer energy level. And sodium, of course, being number 11 in the periodic table, has 11 protons. And I'll just quickly draw the others. But as you can work out, I'm sure, the really important electrons, or electron only in this, is that outer one, the valence electron. And now let's do chlorine. So chlorine's here, period 3, so 3 energy levels. Good. And it's in period 7, and so it's got 7 electrons in its outer energy level. And that's important. We'll draw the others. They're not so important, but I still want to draw them for now because they are there. Now, we've got this situation where, oh no, I have drawn 7 there, where chlorine is not stable. In order to become stable, chlorine needs to have 8 electrons in its outer energy level. Argon is stable. It has 8 electrons. Chlorine, not so much. If it does a chemical reaction, it's going to need to get to that because that's stable. That's the only reason it will do a chemical reaction, in order to become more stable. And so it's going to need to gain an electron. Where's it going to get that? So I'm just drawing the number of protons there for a moment. We go now to sodium, back here. It has 1 electron in its outer energy level. Gaining 7 more electrons is not really feasible. There'll be all of these electrons in the outer energy level repelling each other with their same negative charges without enough of a positive charge in the nucleus to attract them in place. That doesn't happen. So instead of gaining 7, it loses 1. And if it loses 1 electron, well, it becomes like neon. Well, it's like neon, but one of its electrons has gone away. And now it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. 10 negative charges. It's sodium, and the definition of a sodium atom is that it has 11 protons, 11 positive charges. So its negative charge is 1 less than its positive charge. So its net charge is sodium plus 1 single positive. So you can see that by losing an electron, sodium gains an electron structure that's the same as a stable atom. But in doing so, it loses a negative charge and becomes Na+. And that's pretty convenient for chloride, because chloride can now take that here, and now chloride has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18 protons, 18 electrons. It's chlorine, and the definition of chlorine is 17 protons. It's now got 18 electrons, so it's now 1 more negative than the number of positives. It's a chlorine ion. These are no longer atoms. An atom has the same number of protons and electrons. An atom has no net charge. An ion keeps its number of protons because it's the same element, but it changes its number of electrons. and in doing so, it gets a net charge. And that net charge, if it loses an electron, is a positive charge. This is a cation. Its net charge, if it gains an electron, is a negative charge. And this is an anion.